The ledge was barely 18 feet wide. On one side, solid granite. On the other, open air and a drop of hundreds of feet into the valley below. A Caterpillar 60 bulldozer sat there, engine running, in the summer of 1932. The bulldozer weighed approximately 20,000 pounds. Its steel tracks, 20 inches wide, spanned nearly the full width of the cut. The operator had nowhere to turn. One wrong move and both machine and man were gone. This was the final push to complete Going to the Sun Road, 11 years of work converging at the east side of Logan Pass at 6,646 feet. The bulldozer had to finish what the blasting crews had opened. No one had written a manual for operating a bulldozer on a ledge barely wider than the machine itself. The operators who took that job learned on the face of the mountain. The season was already shortening. There was no time to hesitate. But to understand what that bulldozer was up against, well, we have to go back to the beginning, back to when Glacier National Park engineers first decided to carve a road directly into the face of the Garden Wall, one of the steepest cliff traverses in the American West. The route chosen by engineers required cutting a continuous road bench directly into solid rock, for miles at altitude with no flat ground anywhere to stage equipment. Before any bulldozer could work, our temporary access roads had to be blasted and graded just to reach the job site. The Caterpillar 60 was the machine selected for the most demanding sections. Its four-cylinder gasoline engine displaced 1,128 cubic inches and ran at 650 RPM. Not fast, but relentlessly torquey. The bulldozer was built to push, not to hurry. Some of the bulldozer's blade was cable-operated, raised and lowered by a drum winch mounted directly behind the operator's seat. No hydraulics. The operator controlled depth with his hands, his feet, and his feel for what the rock beneath the tracks was doing. The tracks themselves were the bulldozer's lifeline on the Garden Wall. 20-inch wide grouser pads, 5-roller platform per side, ground pressure of approximately 5.4 pounds per square inch, low enough to work on loose rock without punching through the ledge edge. By 1931, the bulldozers working the west side of Logan Pass had largely finished their section. What remained, the final 10 miles on the east slope, was the most technically brutal terrain the machines had yet faced on the entire project. Two contractors were awarded the east side work, Colonial Building Company of Spokane and A.R. Guthrie of Portland. Both faced the same problem. Their bulldozers had to operate on ledges where there was no room to reposition, no room to turn, and no margin for error. To get a bulldozer onto Guthrie's section of the east face, the machine had to be barged across St. Mary Lake. There was no overland route. The bulldozer floated in on a flat-bottom barge, then drove off onto raw mountain ground that had never held a machine before. If you want to see how these bulldozers push through one of the most dangerous construction jobs in American history, here's what I ask. See that subscribe button? It's our exchange, your way of saying this reached you. Hit subscribe if this resonated. Drop a like if it moved you, and tell us in the comments what you know about Going to the Sun Road. It helps us share more stories like this. Back to the bulldozers on the mountain. The standard working technique on the Garden Wall was push back, but push again. The bulldozer moved material in short increments, never more than the ledge footing could absorb. Every blade load was calculated against the weight of the machine and the angle of the cut. Tipping material over the downhill edge was deliberate and controlled. The bulldozer eased its blade load toward the void in small, measured movements. Below the ledge, thousands of tons of blasted rock accumulated on the slope, every pound pushed there by the blade. The operators worked with no cabin closure. A wind crossed the Garden Wall at altitude with enough force to carry away tools left unsecured. Canvas coats, leather gauntlet gloves, and goggles were the only protection. Cold, grit, and engine noise were constant. Steering the bulldozer on the ledge required managing 2 independent dry disc clutches, one per track. To turn left, the operator released the left clutch and applied the band brake. Precise, physical, and unforgiving if mistimed on loose stone. All the mechanical evolution of bulldozers, history's most punishing projects, and the technical details no one else covers, that's what lives in the membership section. Join and you get full access to 20-plus minute deep dives built for people like you. Now, back to the Caterpillar 60 on the Garden Wall. The bulldozer's 3-speed transmission was the operator's primary tool for controlling force against the rock. First gear for direct pushes into fresh blasted rubble. second gear to back along the ledge. Third gear rarely used, there was nowhere to go fast. The construction season on the east side ran from early June to mid-October. Outside those dates, snow sealed the pass. The bulldozers worked every available day. First light to last light, that each hour of machine time on that ledge was irreplaceable. Rock excavation on the narrowest sections meant the bulldozer could only push material in one direction, over the edge. There was no room to stockpile, no room to spread. But the blade had to place every cubic yard of waste rock precisely over the cliff. 3 workers died during the construction of Going to the Sun Road. The bulldozer operators understood the arithmetic clearly. Any machine failure, any track slip at the wrong moment, meant the same outcome. They worked with that knowledge every single day. When rockfall blocked the path, the bulldozer cleared it. When ice sheeted the ledge overnight, the machine waited until the freeze broke. When a section of cut face sloughed away, some of the blade went back into it. The bulldozer's answer to every obstacle was the same: push. Maintenance on the mountain was constant. The 5 roller track bogies accumulated granite grit that accelerated wear. Operators carried spare pins, split links, and a 16-pound sledgehammer. A broken track on that ledge was not a delay, it was a crisis. The blade edge itself wore down against the constant abrasion of granite. A dull blade pushed less efficiently, demanding more engine load for the same result. The operators learned to read blade performance, the way the cut changed, the way the tracks loaded, and adjusted accordingly. Summer rains slowed the bulldozers. Freshly cut granite turned slick with runoff, and the grouser pads lost grip on wet stone. Operators learned the hard limit: push too hard on a wet ledge and the machine walked sideways toward the drop. Rain meant stop. When the blade pushed against the cliff wall on the uphill side, the bulldozer sometimes stalled, the rock too hard, the angle too steep. The operator dropped to first gear, increased throttle, and leaned the machine into the cut until something gave way. The 60 rarely lost that argument. The bulldozers built the road to its own specifications. The road width was set at 22 feet across most of the route, but along the narrowest garden wall sections, the bulldozer's own operational width effectively defined the minimum. The machine set the margin. Turning the bulldozer when a section was complete required a spotter on the downhill side, a laborer whose only job was to watch the track edge and call the stop. The operator could not see the drop from his seat. He trusted the voice. He had to. By late summer 1932, the east side bulldozers were closing the gap between contractor sections. Surveyors confirmed the alignment was true. The blades were working toward each other across the final few hundred yards of unfinished mountain. October arrived and snow dusted the summit. The bulldozers worked harder, extending shifts until the light failed completely. Every yard of rock cleared before the freeze was one less yard for the following season, or for the prospect of no following season at all. The Caterpillar 60's engine ran at 650 RPM under load, a steady, heavy sound that carried across the mountain face. Construction crews on the west remembered hearing the east side bulldozer long before they could see it. The machine announced its own progress. In the late fall of 1932, the final blade pass happened. The bulldozer scraped across the last section of rough-cut roadbed and stopped at the junction where the 2 sections met. The blade settled, the engine idled. The cut was complete. The first automobile crossed the full 51 miles of Going to the Sun Road in the late fall of 1932. It drove on a surface that the bulldozer blades had leveled. The road existed because the machine had forced it into the mountain, yard by yard, ton by ton. If these stories mean something to you, take a look at the thanks button below this video. It's a small gesture, but it's the most direct way to say you want more of this. Let's continue with what the Caterpillar 60 left behind on Going to the Sun Road. The Caterpillar 60 went out of production in 1931, but the same year the final east side push began. The machines on Going to the Sun Road were among the last built. They finished a road that will outlast every machine that ever touched it. The project's total cost exceeded $2.5 million, over 20 times the original congressional estimate. Most of that money paid for machine hours, fuel, blades, track pins, engine overhauls. The bulldozer earned every cent of it on that mountain when the road was formally dedicated on July 15, 1933. No bulldozer was present at Logan Pass. The machines had already moved on to other contracts, other mountains. The road they cut into the garden wall stood as their only monument. The blade cuts made by those bulldozers in 1932 are still visible in the rock face today. The steel scoring marks survive under 90 years of weather, ice, and lichen growth. The mountain absorbed the machine's work and kept a record of it permanently. The road was never truly finished in 1932. Paving and improvement continued for decades. The last section was not surfaced in asphalt until 1955. But in every year between 1932 and 1955, bulldozers were back on that mountain doing the work that remained. In 1964, a bulldozer and its operator triggered a wet snow slab on the road and were both carried over the edge. The operator survived, injured. 3 decades after the original construction, the mountain was still taking the same toll on machines and the people who ran them. Today, the annual spring snowplow operation depends on bulldozers making the first cut through snowpack that still reaches 60 feet at the summit. The technique is direct. Push the snow over the downhill edge, back up, push again. The same logic as 1932. The same mountain. Since 2007, approximately $80 million has been spent rehabilitating Going to the Sun Road. Bulldozers are part of every phase of that work: slope stabilization, drainage reconstruction, roadbed repair. See, the machine that built the road is still maintaining it. The road was designated a National Historic Landmark in 1997. The first road simultaneously registered as a National Historic Place, National Historic Landmark, and Historic Civil Engineering Landmark. The bulldozer cuts in its rock face are part of what makes it historic. Some areas of the road are only 8 feet wide. Even today, modern bulldozers working the rehabilitation face the same fundamental constraint as the Caterpillar 60 in 1932. The mountain has not widened. Yes, the problem has not changed. Only the machines have. On unstable sections, modern bulldozers are restricted from using vibratory compaction. The vibration can trigger rockfalls on workers below. The same slope instability that challenged the Cable Blade 60 in 1932 still governs how every machine on this road must operate. The Caterpillar 60 was described by engineers who worked with it as a machine better than it should have been. A balanced design where power, suspension, and frame came together beyond what the specifications suggested. On Going to the Sun Road, that balance was tested completely. What those bulldozers proved on Going to the Sun Road was replicable. The construction methods traveled to other alpine projects across the American West, always with the same machine at the center, always pushing, and always adapting to what the rock demanded. Most of the Caterpillar 60 bulldozers built in the final production years were scrapped within a decade. Worn out by jobs exactly like Going to the Sun Road, pushed beyond their design hours on granite, in altitude, without rest. They gave everything the mountain asked for. The Caterpillar 60 is at rest now, but the cuts it made in the garden wall are still open. Still carrying travelers across the Continental Divide at 6,646 feet, 90 years after the last blade pass. If this story moved you, please like and subscribe. Your support helps us preserve these machines and the histories behind them. Tell us in the comments where you're watching from.